Hello again, everybody. Today we're going to be doing some homework correction again of theoretical probability questions. I know we've been doing a lot of homework and question type lessons in the last few videos, but I actually think it's actually a good thing to see more question types like this, because it is a topic that we don't necessarily see a lot of at first in school, but it does come up quite a bit if you're playing games or rolling dice, or some people like to go to Vegas sometimes and gamble, which is always a dangerous thing to do, so be very, very careful. The cards are always stacked against you, no pun intended. So, but it is something, probability is something that happens quite a bit in the real world, so I think, like I said, the more questions we see, the better. So let's get at it. So this is the first question from the homework. A card is randomly selected from a standard deck of cards. Write the theoretical probability of each event as a fraction in lowest terms. So a standard deck of cards is 52 cards. So we want the theoretical probability. So this is the actual, what should happen if you were to do it a million times, okay? Or a billion times, or an infinite amount of times. So what is the theoretical probability of pulling a spade? Well, how many spades are there in a deck of cards? Well, we saw the other day that there are 4 different suits, and each suit has 13 cards. So the probability for a spade, and this is letter A here, would be 13 out of 52. So the 13 out of 52, as we mentioned the other day, you can think of this, yes, there are 13 spades out of 52 cards in the deck, but the spades count as one suit out of 4. So because this is a proportional relationship to that idea, there's one suit out of 4, this actually will become 1/4. And I'm going to let you try to figure out how that is. And this would give us a percentage of, well, before the percentage, it would give us a decimal of 0.25 and a percentage of 25%. Okay, so pulling a spade out of the deck is the same probability, whether we think of it as pulling one suit out of a deck of 4 suits. So that's an interesting little relationship there. The B is the probability of a face card. How many face cards are there? And we're going to see that kind of proportionality again. So there are 3 face cards per suit, the Jack, Queen, and King. That means there are 12 face cards in all. So probability is 12 out of 52. But thinking of proportionality, how many face cards are in one suit? There are 3 face cards in one suit of 13 cards. So these two are proportional fractions, but you can think of it as 2 different ways. You can think of it as 12 cards, the 12 face cards, out of the full deck of 52, or you can think of it as 3 face cards out of one suit of 13 cards. Both of these give the same result. And I'm going to let you fill out the decimal and percentage values from that. You just have to divide them. If you didn't get it right in your homework, just divide these, find the decimal, and then convert it to a percentage. Letter C. Now this is interesting. We kind of talked about this briefly in the last video. You can actually find the percentage of not getting something. Okay? Now, not getting a face card is the complement of getting a face card. And I'm going to write that underneath here. So in probabilities, when you have one probability that gives you the probability of doing something, and then the next probability is the probability of not getting that thing, that is called the complement. And the complement is always the difference. So it could either be from this fraction or this fraction, the difference from the top number to the bottom number, because 100% would be 52 over 52. 52 divided by 52 is 1. 1 times 100 is 100%. Well, if I asked you what's the probability of getting any card from a deck, it would be 100%, because you'd have 52 chances out of 52 to pick whatever card is in the deck. 12 of them are face cards. How many of them aren't face cards? Well, if 12 of them are face cards out of 52, the rest of them have to be non-face cards. So basically we can do 52 minus 12, and I'll write this off to the side in red to match the complement. So 52 minus 12, which would be, well, 52 minus 2 is 50. 50 minus 10 is 40. So the complement could be written as 40 out of 52. Or, and we can do the simplification of the fraction, okay, we can simplify this fraction, but I had said that we can also think of this, even though it's a simplification of this fraction, 3 out of 13 can be thought of as 3 face cards out of 13 in one suit. Well, if there's 3 face cards out of 13 in one suit, how many non-face cards are there out of 13? Well, the difference would be 10. So we know that 10 out of 13 would be the complement of 3 out of 13, just like 40 out of 52 is the complement of 12 out of 52. And it just so happens that if you divide the top and the bottom by 4 here to simplify the fraction, you will get 10 out of 13. So there's a lot of different ways of getting to the final answer here once you start to kind of understand the idea of proportionality as well as probability. So I just wanted to talk about that. For a black jack, well, how many black jacks are there in a deck of cards? Well, there's the jack of spades and the jack of clubs. So there are 2 black jacks out of 52. If we want to simplify this fraction, both of these are divisible by 2, which gives us 1 in 26. For letter E, a red or a black card. Well, to pull a red or a black card, every card in the deck is either red or black. So this is a 52 out of 52, which we haven't, I don't think we've actually seen an example. I kind of mentioned it up a little bit above here, that it can happen, but this is the first time we see this. 52 divided by 52 is 1. 1 is already both a reduced fraction and a decimal. So to convert it to a percentage, this is 100%. There's a 100% chance of picking a red or a black card. I could ask a question like, what's the percentage of picking a purple card? Well, that would be 0, because there are no purple cards in a deck of cards. The last one is a red face card. And the probability of pulling a red face card, well, how many red face cards are there? There's the Jack, Queen, and King of Hearts, and the Jack, Queen, and King of Diamonds. So there are 6 face cards out of 52. And again, we know that these 2 numbers are divisible by 2. I'm going to let you figure out the decimal and percentage values for that one. So that's question number 1. Once again, if you have any questions about how I came up with any of the answers for these, please let me know through email so I can get back to you. Question 3. Brit rolls a regular 6-sided dice. Find the theoretical probability of each event. Express your answer as a fraction in the lowest terms. So what is the probability of rolling a 6? Well, if we quickly draw our little chart for our dice here. What's the probability of rolling a 6? Well, it's 1 in 6. There's one success. And I'm just going to take that away in case I need that picture later on. So there's a 1 in 6 chance of rolling a 6. What is the chance of rolling a number greater than 3? Well, how many numbers are greater than 3? 1, 2, 3. So the probability of rolling a number greater than 3. I'm going to use the symbol for greater than, just so I don't have to write the word. And there's a 3 in 6 chance, which means 1/2 if we reduce that fraction, which means 0.5 and 50%. So again, up here, I'm going to let you figure out the decimal and percentage for A. Rolling an 8. Well, on a 6-sided die, the percentage of rolling an 8 is 0 out of 6, which is just 0. There is no chance of rolling an 8. Last one is rolling an even number. How many even numbers are there on a die? Well, 2, 4, and 6. There are 3 out of 6, which is the exact same percentage as B. So again, I'm going to let you finish that one off. Okay. Okay. A pet store has 10 cats, 12 dogs, and 3 turtles. If Bobby randomly selects a pet to take home, find the theoretical probability of getting a cat. Well, he's picking randomly, or she, I guess it could be a he or she, is picking randomly from these animals. Well, what are the total possibilities? So the total possibilities is equal to 10 plus 12 plus 3, which is 25. Okay, so there's 25 different possible selections. What is the probability of getting a cat? Well, how many cats are there? There are 10 cats out of a total possibility of 25. Now, if we divide that by 5, we get a 2 in 5 chance. Okay, and once again, I'm going to let you calculate the decimal and percentage value. Probability of getting a turtle. Well, there are 3 turtles out of a total possibility of 25. Now, this is not reducible as a fraction, but you can calculate the decimal and the percentage, which I'll let you do. And the last one is the probability of a dog or a turtle. I'm just going to move this down a bit so it's not in the way. Well, for a dog or a turtle, you've got 12 dogs and 3 turtles. So that's 15 out of 25. This actually does reduce, and again, I'm going to let you do that, calculate the decimal, calculate the percentage. Okay, so that is the those are the solutions to that question. Now this is an interesting one. Suppose you roll 2 6-sided dice. Find the theoretical probability of rolling each sum. So in this case, we might want to use our tree, and it will be a little bit, it's going to take up a little bit of room here. So instead of drawing the whole dice, I'm just going to draw a dot for the die. 1, 2, 3, 4, 5, 6. So those are our 6 first rolls, and each one of these has 6 more. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. So I just staggered these a little bit so that they're not overlapping each other. Still pretty tight, but we'll make it work. Okay, so now rolling two six-sided dice, as I had mentioned in one of the previous videos, is the exact same thing as rolling one die twice. Okay, so this tree here, the event tree, is the exact same whether you're rolling the same die twice or two six-sided dice. So what is the theoretical probability of rolling each sum? Now you may not have needed this for A. You may have needed it just to figure out how many total possibilities there are. So our total possibilities is 36. Okay, so where are we going to roll a 2? Well, the only way to get a 2 on two dice is by rolling a 1 and a 1. So there's only one chance of that. So the probability for A of rolling a sum of 2 on two dice is 1 out of 36. And I'm going to let you figure out the rest. For B, an 11. Well, what are the two possible ways, or the only possible ways of rolling an 11? Well, an 11 is 5 and 6. So you could either have 5 and 6 on one die combination or 6 and 5 on the other die combination. Okay, so there's 5 and 6 here, 6 and 5 here. I'm not circling these. I hope you can see my cursor moving. So the probability of getting an 11 as a sum is 2 out of 36. For C, a sum greater than 5. Again, I'm going to use the greater than symbol here. Well, sum greater than 5 means any value that's going to be, 6, 7, 8, 9, 10. What is the greatest sum you can get on two dice, by the way, is, you know what? I just realized I did 5 and 5 up here. It's 6 and 6. Okay, so the greatest sum you can get on two dice is 6 and 6, which is 12. So all of the sums from 6 to 12 are the ones that we're looking for. Well, 4, if we go to 4, 4 plus 6 is 10. If we go to 3, 3 plus 1 is 4. Where do we start getting the sums that are greater than 5? Well, it's always going to be wherever the two sums are greater than 5 in the branches. So 1 and 4 is 5. That means 1 and 5 is greater than 5, and 1 and 6 is greater than 5. So that might have been a little bit too complex of a way to figure that out, but that's the way my brain decided to do it here. So I am actually going to highlight those ones just because I need to count them all and I'm going to lose track. Okay, so where's the sum greater than 5? Well, 2 and 3 is 5, so that means there's 3 of them here. 3 and 2 is 5. That means there are 4 of them here, and now there's an interesting pattern that seems to be coming up. 4 and 1 is 5, so that means there are 5 of them, and I think you're starting to see 5 and 1, so all 6 of these, and 6 and 1, and all 6 of these. Okay, so there's 2 plus 3 plus 4 plus 5 plus 6 plus 6. So 2 plus 3 plus 4 plus 5 plus 6 plus 6. So those are all of the sums that are greater than 5. So there's 5, 5 plus 4 is 9, 9 plus 5 is 14, plus 6 is 20, plus 6 is 26. So there is a 26 out of 36 chance of rolling a sum greater than 5. And that means if we look at the complement, what would be the chance of rolling a sum smaller than 5? That would have to be 10 out of 36, because the complement of 26 to 36 is 10, the difference in other words. Okay? So it would be 10 out of 36 to roll something smaller than 5. For D, what is the probability of rolling a 7? Now, you might have noticed there's a game in the casino called Craps that rolls 2 dice, and they're often asking for a 7 or an 11. Okay, so that's kind of why these two numbers, the 7 and the 11, are being highlighted here. So the 7 here and the 11 here. I can't highlight it. Anyway, so what is the probability of rolling a 7? Well, how do we get 7s on 2 dice? You get 7s with a 2 and a 5, a 1 and a 6, a 3 and a 4, 4 and a 3, and then 6 and a 1. Okay, so I'm going to use a different color for this one. I'm going to use purple. Okay, so we've got 1 success here, 1 and 6, 2 and 5 is 7, 3 and 4 is 7, 4 and 3 is 7, 5 and 2 is 7, 6 and 1 is 7. So there are 1, 2, 3, 4, 5, 6 different ways of rolling 7, out of a total of 36 different combinations of 2 dice. Rolling a 7, by the way, on 2 dice is the roll that has the highest probability. And the last one is not a 7. So the probability for E of not rolling a 7 is the complement of rolling a 7, and the difference between 6 and 36 is 30. So the complement is 30 out of 36. So the most likely roll is a 7, but it's still not as likely as not rolling a 7. So hopefully that was clear enough. Again, any questions, please email me to let me know. During a game of musical chairs, 10 people walk around 8 chairs, waiting for the music to stop. Find the probability of a person not getting a chair. Well, if there are 10 chairs, and if there are 8 chairs and 10 people, how many people won't get a chair? So in this case, the success is the number of people not getting a chair, even if it's not successful for those people, but it's the successes we're looking for in our little activity here. So probability of not getting a chair, sorry about that, would be 2 out of 10. 2 out of 10. That's right. You might wonder, why is it not 2 out of 8? I actually hesitated myself there for a second. And the reason is it's the number of people that is our total. Because there are 10 people in total, how many of those people aren't going to get a chair? So the 8 is just there to help us figure out what that is. Okay? if I was to ask you what is the probability of a person getting a chair, well, how many of the 10 people are going to get a chair? That would be the complement of 2, which is 8 out of 10. So you got to be a little bit careful. Sometimes they will throw in numbers like that that are there to help you find the answer, but don't partake in the actual math like directly. So 2 divided by 10 is an easy calculation. You just move the decimal place 1 to the left. So we'll do that one together. And then multiplying by 100 gives 20%. So there's a 20% chance of you not getting a chair in this activity. For the next question, suppose you roll 2 6-sided dice again. Explain why the probability of rolling a sum of 14 is 0. Why? Well, can you roll 14 with 2 dice? The highest roll is 12. So you can't roll a 14 on 2 dice. So that's why the probability is 0. Explain why the probability of rolling a sum from 2 to 12 is 1. Well, a probability of 1 means 100%. There's a 100% chance of rolling a sum from 2 to 12, and that's because that's what all of the sums on 2 dice equals. There's no other sum, so you have to roll a sum of 2 to 12. So there's multiple different ways of explaining this one. As long as it's something similar to what I wrote here, you should be good. Ronald's Restaurant offers this sandwich menu. So you have tuna, egg, and ham, and then your choice of whole wheat or white bread. And it says how many different types of sandwiches are possible. So let's draw our event tree. Okay, so we have our order, and our order is either going to have white. Actually, that's the second option, so I'll put that in the second column. I guess I have to erase it. So white, or whole wheat. You then have 3 choices of meat for both. Tuna, egg, or ham. Same thing for the white. Tuna, egg, or ham. So the first question says, how many different types of sandwiches are possible? Well, there's 1, 2, 3, 4, 5, 6. So there are 6 different types of sandwiches. And then part B says, suppose you like all sandwich fillings and both types of bread. If you randomly selected a sandwich, what is the probability of each sandwich being tuna on white bread? Well, white bread is here, tuna is here. So for this one here, there is 1 success out of 6. So for part B, that is 1 probability. I'm just going to write probability of I. How's that? So I don't have to, and then that's equal to 1 over 6. The probability of double I, egg salad or ham on whole wheat bread. Well, I'm going to use blue for that one. Egg salad or ham on whole wheat bread. There are 2 out of 6 possibilities for that one. Probability of 3 is ham. I'm going to use red for that one. Well, ham is here and here, so there are 2 out of 6 possibilities for ham. And then egg salad on white or whole wheat bread. I'm going to use green for that one. Egg salad on white, which is here, or whole wheat bread, which is there, and that's again a probability of 2 out of 6. And 2 out of 6, 2 out of 6, 2 out of 6, those all reduce. I'll let you figure out what they reduce to. And I believe that is it for the homework questions. I think I had assigned number 10 as well, but number 10 requires you to look at the example from the book. I don't have the example of the book handy, so I'm going to let you try to figure that one out on your own. And if you have any questions, please email me. We're not going to be doing anything new today, so that is the end of today's lesson. And there's no homework this time around. So we will continue tomorrow with a new lesson. Please take care of yourselves, and we'll see you soon.